Today's section is called Mass and the Mole. So yesterday I talked about how with Avogadro's number and the number of particles in a mole, that a mole is not actually mass or volume, it's strictly just a counting number, much like the term a dozen. And so with that, if we consider something like 12 limes or 12 eggs, they're the same number of counting item right there, but they don't weigh the same, they don't take up the same amount of space. In the same way, if I had 1 mole of hydrogen gas, which is this H2 right here, it's not going to have the same mass as 1 mole of C6H12O6, which is glucose. They're going to weigh different amounts. I'll have the same number of particles present, but they're going to weigh different amounts. So how does the mass of one atom relate to the mass of 1 mole of that atom? And this is where your periodic tables are going to be helpful for you. So if you don't have that out, go ahead and grab it. Okay, so a mole is exactly 12 grams of carbon-12 atoms. How many that would be, right? We talked about that in yesterday's video. But the mass in grams of 1 mole of any pure substance is called its molar mass. Okay, so on your periodic tables, the molar mass of any element is numerically equal to its atomic mass and has the units grams per mole. Okay, so if we look at, say, something like, chromium, Cr, okay, it has an atomic mass of 52.00 AMUs. Right? That's how many protons, neutrons, and electrons all add up to that mass. But it also can be used as what we call molar mass, which is this guy right here. It has this symbol. It's got this cursive capital M. Basically, scientists were running out of M, so they used a cursive capital M to represent molar mass. Chromium is also 52.00 grams of chromium for every 1 mole of chromium. So if you weigh out 52 grams of chromium on the scale, you have exactly 1 mole of it in front of you. This is really nifty. So basically we are just using AMUs and molar mass interchangeably. So we can figure out exactly how many moles we have of something just by knowing its molar mass, and that's already done for you on the periodic table. So just for example here, if I had some iron and I looked at the periodic table, it's got a atomic weight of 55.845 AMUs, right? That's its atomic mass. But it's also its molar mass, 55.845 grams per mole, which means if I go and put iron on a scale and I weigh out 55.845 of it, this is what 1 mole of iron would look like. It's also, if we're considering number of particles, 6.02 times 10 to the 23rd atoms of iron, give or take a little bit there, right? Because we're dealing with significant figures. But we have basically 2 ways to calculate information from that. If we put this mass up there, we can figure out how many moles there are. We can also figure out how many particles there are. So, let's say you are in a lab, and I ask you, you need to get 2.50 moles of aluminum for a reaction. So what are you going to do for this? Basically, you're going to need the equation to get you there. And it's going to look like this, that molar mass is equal to mass divided by moles. I know that's a lot of M's there, right? Okay. This is molar mass, right? The cursive capital M, that comes off the periodic table. Mass, this is coming off a scale. It's got to be in grams, can't be in kilograms, got to be in grams. And moles are either given to you or you're asked to solve for it. So here it says, what if I need 2.50 moles of aluminum for a reaction? Well, I don't have a scale in the lab that measures in moles. I have a scale that measures in grams. So if I could figure out how many grams that is, I can weigh that out on the scale. So if I solve this equation for moles, I bring moles up to the left side. That's what we're doing over here. Multiply both sides by moles, and then I get mass over here is equal to moles times molar mass. That's what's going on right there. I'm just rearranging this equation. It's just algebra. Right? It's just A equals B over C and rearranging that. Well, so that means it's molar mass times moles. Well, here's the molar mass, 26.98 grams of aluminum per mole. That's coming from the periodic table, if you go look up aluminum. And 2.50 moles was given to you in the problem. We multiply those together, 67.4 grams of aluminum. So if you needed 2.50 moles of it for something in lab, you would weigh out 67.4 grams of aluminum on the scale. Kind of a nifty conversion there. So we can go straight from how much it weighs into how many moles are present. So just another example here, what's the mass of 2.15 moles of silver atoms? Well, I'm going to get mass by itself, so bring moles over to the left, right? Multiply both sides by moles. Okay. And then my molar mass for silver is 107.87. By the way, pretty much going to always round molar masses to the hundredths place, so just kind of get in the habit of doing that. 107.87, and then times the number of moles is 2.15 moles equals 232 grams of silver. Notice I am paying attention to significant figures along the way. Okay, this one has 5, this one has 3, my answer only has 3, 232. What is the mass of 4.25 moles of CH4? Okay, now I don't just have an element here. What do I do when I'm asking about moles of a compound? So what I need to do with the molar mass is add up everything that's a part of the compound. Okay, I'm going to add up what one carbon is plus 4 hydrogens. So to determine the molar mass first, carbon is 12.01 grams per mole from the table, and I've got one of them, plus I've got 4 hydrogens, and each hydrogen's mass is 1.01 grams per mole. And I do that math, I get 16.05 grams per mole for methane. So even with compounds, we can figure out their molar masses. We just have to add up everything that's in it. Right? This one was pretty easy, 1 carbon and 4 hydrogens. Okay, that's all you got to do. And it says, what's the mass of it? So once again, I'm just rearranging this equation. Okay, so canceling out moles on the right, and getting, right, mass is equal to molar mass times moles, the same thing we've seen the last 2 slides. Okay, the molar mass here is 16.05, right, we're rounding it to the hundredths place, times the number of moles, 4.25 is 68.2 grams of methane is what CH4 is. So once again, rounding to 3 significant figures. How many, we're going to go ahead and skip this slide, don't worry about this one, it's kind of got all messed up. How many atoms are in 94.2 grams of carbon? So now we can actually kind of take a look and go from mass to number of atoms. Right? If I'm starting with mass, I have a conversion with molar mass to get me into moles, and I've got a conversion from moles to get me into number of particles. So I can figure out roughly how many atoms are in 94.2 grams of carbon. So the first thing to do is convert mass to moles. So to do that, I got to get moles by itself. So I'm going to do that right there. I'm going to cancel moles, and then I've got moles times molar mass is equal to mass. And then I'm going to divide both sides by molar mass. Okay, and that leaves me with moles are equal to mass divided by molar mass. Alright, so that's another form of this equation. I'm going to plug in the mass, which is 94.2 grams, divided by the molar mass off the table. Gives me 7.84 moles of carbon, with 3 significant figures. And then to get it to number of particles, I just take the moles times Avogadro's number, 6.02 times 10 to the 23rd particles per mole. Okay, and since this is a single element, we're talking about atoms, this is 4.72 times 10 to the 24th atoms of carbon. So starting from grams, I can get all the way to figure out how many atoms there are, roughly. Okay, so this is a really, really helpful chart. You're definitely going to want to put this into your notes and then star it or highlight it or something. This is kind of a cheat sheet of how to get between stuff. So in case you don't want to have to think about it every single time, this is super helpful. We've got 3 things that I could ask you to solve for. Particles, moles, or mass. Right? There's 3 things, and there's really only a couple of things to do to get in between them. So if I want to go from particles to moles, I'm going to divide by Avogadro's number. If I'm going from moles to mass, I'm going to multiply times the molar mass of the substance. So I can go all the way from particles up to figuring out how much it weighs by doing those 2 things. Okay? Or if I'm starting at mass and I want to know how many particles, right, I would divide it by that substance's molar mass. I'd have to figure what that is. And then times Avogadro's number to get me to number of particles. So you can jump from moles to mass, or mass to particles, or particles to mass, or particles to moles, just following this chart right here. Okay, that should get you all the way through your worksheets.